not within the identicals. In other words, Adam is the same as Adam because we have those two A's and we can't tell the difference between them. So we don't have any repetition here. So what we're going to do is we still have the 4 times 3 times 2 times 1 because we have the four letters to arrange. Now what we have to take into account is the fact that 2 of the letters are exactly the same. So what I'm going to do is divide out how many ways can I arrange those 2 A's. Oh, 2 times 1. So the reason we're dividing is the order of the A's doesn't matter. So that's why I'm dividing. Okay? So this is definitely challenging to see. All right, let's go to the next page. Okay, so now we have to add another twist. Now we have these 5 letters. So what we would normally do is, we can arrange those 5 times 4 times 3 times 2 times 1 ways. The problem is we have the L's are repeated and the A's are repeated. So what we have to do is we have to divide by, because I tell you there are 10 possibilities. Here's how you would do it numerically. We have to divide by how many ways can I arrange the L's? Well, there are 2 of them, so I can arrange them in 2 times 1 ways, times how many ways can I arrange the A's? Oh, there are 3 of them, so 3 times 2 times 1. And so what that's going to equal is our 10. So this here is the order. We have to divide out the fact that the order of the 2 L's doesn't matter. Okay, and here, these 3 times 2 times 1, the order of the 3 A's doesn't matter. So we're dividing out, we have to divide out the order, we have to divide by the number of ways the identical objects can be arranged, is what we're essentially doing. We have to say, well, we can't count these extra ways. I didn't write out all 120 ways that we could arrange those letters, but ultimately there are only 10 different arrangements. Okay? So let's go ahead and write down permutations with repetition by the definition would be, or what that means is we need, and I'm not going to, you know me, I don't ask for definitions, but you need to divide by the number of ways identical objects can be arranged. And, by the way, I'm also going to post on Haiku my key, if you have trouble following me here, which is much neater. All right. Okay, so I'd like you to try example 3 on your own, please, and then go ahead and start the recording once you've tried them. Okay, so I'm looking at Mississippi and realizing there are 11 letters, so I'm going to write that as 11 factorial, 11 times 10 times 9 times 8 times 7 times 6, blah, 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 divided by, okay, I have the S's are repeating, and there are 4 S's, and then, so I got to take those away, right? And then I also have the 4 I's, so I have to divide by 4 factorial, and then the 2 factorial. Here's the thing. If you can see I'm more concerned with the setup rather than the answer. If you are going to put this in your calculator, make sure the denominator is in parentheses. Otherwise, you're going to get the wrong answer. And so now for onomatopoeia, there are actually 12 letters. And then the repeats, I have 4 O's and I have 2 A's. Again, if you're going to use your calculator, And you are allowed to use your calculator, by the way. You would do 4 factorial times, divided by parentheses, 4 factorial times 2 factorial. Please make sure you show all your work, because that's what I'm looking for is the setup. So, looking here, oh, yeah, just a second. Okay, I had to get it so I could see, you could see that whole, this whole next problem. So, find the number of roots. This is a pretty cool application, you might say, of the, you know,